The birth and death of stars. Stars are among the most fascinating objects in the universe. They light up the night sky, create the elements that make up our world, and shape the destiny of galaxies. But like all living things, stars are born, they live, and eventually they die. Their story is one of transformation, beauty, and power. The story of how the universe evolves. Stars begin their lives deep inside vast clouds of gas and dust called nebulae. These clouds are mostly made of hydrogen, the simplest and most abundant element in the universe, along with smaller amounts of helium and traces of heavier elements. Over millions of years, parts of the nebula begin to collapse under their own gravity. As the gas and dust fall inward, they start to heat up. The material forms a dense, spinning core called a protostar. Inside the protostar, gravity continues to pull matter inward, squeezing it tighter and tighter. The temperature and pressure rise dramatically. When the core becomes hot enough, about 10 million degrees Celsius, a nuclear reaction begins. Hydrogen atoms fuse together to form helium, releasing an enormous amount of energy. This moment marks the birth of a star. The energy from nuclear fusion pushes outward, balancing the inward pull of gravity. The star enters what is called the main sequence phase, where it will spend most of its life. During this long stage, a star shines steadily. The balance between gravity and pressure keeps it stable. Our Sun, for example, is a main sequence star and has been in this stage for about 4.6 billion years. It converts around 600 million tons of hydrogen into helium every second, releasing light and heat that make life on Earth possible. However, the life of a star depends mainly on its mass. Massive stars burn their fuel quickly and live short, brilliant lives, sometimes only a few million years. Smaller stars, like red dwarfs, burn their hydrogen slowly and can live for hundreds of billions of years. When a star uses up the hydrogen in its core, the delicate balance between pressure and gravity is broken. The star's fate then depends on how massive it is.
For a star like our Sun, what happens next is gentle compared to the fate of massive stars. The outer layers drift away into space, forming a beautiful glowing shell of gas called a planetary nebula. The remaining core, now very small and dense, becomes a white dwarf. This white dwarf no longer produces energy. It simply cools and fades over billions of years until it becomes a dark, cold object known as a black dwarf, though the universe is still too young for any black dwarfs to exist yet. Massive stars, however, face a much more violent end. When their cores collapse, they can no longer resist gravity. The outer layers fall inward and then explode outward in a tremendous explosion called a supernova. A supernova is one of the most powerful events in the universe. For a short time, it can shine brighter than an entire galaxy. This explosion scatters heavy elements such as iron, gold, and uranium into space. These elements later become part of new stars, planets, and even living beings. In a very real sense, we are all made of stardust. After the supernova, the core that remains can take one of two extreme forms. If the remaining mass is between about 1.4 and 3 times the mass of the Sun, it becomes a neutron star, an incredibly dense object made mostly of neutrons. A teaspoon of neutron star material would weigh billions of tons on Earth. Some neutron stars spin rapidly and emit beams of radiation, becoming what astronomers call pulsars. If the core is even more massive, gravity crushes it beyond all limits, forming a black hole. A black hole has such strong gravity that not even light can escape from it. It warps space and time around it, creating one of the strangest and most mysterious objects in the universe. Yet, Even black holes can play a creative role. When galaxies merge, or when black holes consume matter, they release enormous energy, shaping the evolution of the cosmos. Over billions of years, new stars are born from the gas and dust left behind by dead stars. This cosmic recycling means that the universe is constantly renewing itself. The atoms that once belonged to ancient stars now form planets, oceans, and living beings. In a very real sense, we are all made of stardust. The cycle of stellar birth and death also drives the evolution of galaxies. Young galaxies are filled with bright, hot, massive stars that burn quickly and die in supernova explosions, enriching their surroundings with heavy elements. Older galaxies contain more long-lived, cooler stars and fewer raw materials for new star formation. As time goes on, the universe becomes more complex and rich in elements, allowing the formation of planets and, eventually, life. Even though individual stars have finite lives, the universe itself continues this endless dance of creation and destruction. Each star that dies gives birth to the possibility of new worlds. The light we see in the night sky is a message from the past. Some stars we see today may have already died millions of years ago, but their light is still reaching us. In the far future, star formation will slow as the supply of gas runs out. The galaxies will grow dimmer, filled with fading white dwarfs, neutron stars, and black holes. Yet even then, the memory of the stars will remain written in the atoms of everything that ever lived. Stars remind us that change is the essence of the universe. Their birth brings light and warmth. Their death brings renewal and transformation. They are both the creators and the destroyers, the engines that keep the cosmos alive. Every sunrise, every spark, and every heartbeat carries the legacy of countless stars that lived and died long before us.